So, for a really long time, the scientific community basically thought that once you hit adulthood, your brain was just done. Like you were dealt a neurological hand, and that was it, game over. But actually, that couldn't be further from the truth. Picture this, a realistically rendered brain right in front of you, actively glowing, thickening, and literally building new neural pathways in real time. Whether you're fumbling through a new song on the guitar, solving a tricky math problem, getting lost in a good book, or even recovering from an injury, your brain is this constantly evolving organ. It's shaped by literally every single new experience you throw at it. So today, in this explainer, we're going to totally shatter that old, outdated myth and dive headfirst into the incredible science of neuroplasticity. Okay, let's dive into this. Here's our roadmap for the explainer. 1. Meet your evolving brain. 2. How the brain rewires itself. 3. Simulating neural networks. 4. When plasticity goes wrong. And finally, number 5, habits for cognitive fitness. Let's get started. Section 1. Meet your evolving brain. You know, the old fixed brain myth told us that brain development just hard stopped in adulthood. The idea was that if you lost neurons, well, they were gone forever. You couldn't fundamentally upgrade your cognitive hardware. But the plastic brain reality, that flips the whole script. It shows us that the brain actually adapts and reorganizes itself throughout your entire life. It's continuously building new mental muscle, physically changing its very structure just based on the stimuli it receives. How cool is that? To get a bit precise for a second, let's look at the medical definition from StatPearls. They define neuroplasticity as the ability of the nervous system to change its activity in response to intrinsic or extrinsic stimuli by reorganizing its structure, functions, or connections. Okay, a mouthful, right? But it's an absolutely brilliant concept. Why? Because it's the exact same underlying mechanism that explains both how you manage to learn conversational Spanish on a random Tuesday and how a patient relearns to walk after a traumatic brain injury. It's all the exact same fundamental rewiring process. And this brilliantly illustrates what Dr. Grace Torek at the Cleveland Clinic talks about. She calls it an internal rewiring process that allows your mind to grow and meet new and increased demands. Think about it. Just like you'd lift heavier weights at the gym to build up your biceps, challenging your brain with new tasks literally builds your mental muscle. Moving right along to Section 2, how the brain rewires itself. Now, what's really interesting about this next bit is how we break down the complex medical terminology of functional reorganization. Let's look under the hood. First up, synaptic plasticity. This is where repetitive stimulation actually adds brand new neurotransmitter receptors to a membrane, physically strengthening that connection. That right there, that's the cellular basis of learning. Then there's equipotentiality. This is wild. If one hemisphere of the brain gets damaged, the opposite side can actually just step in and take over that lost function. No way, right? Next is vicariation, which is when the brain reassigns entirely new, totally unrelated functions to a completely different region just to compensate for damage. It improvises. And finally, diachesis. This one is a little different. It describes a loss of function in a brain region that's far away from, but structurally connected to, the site of an actual injury. Kind of like a domino effect. And we can actually watch these mechanisms deploy in real time, chronologically, after a severe event like a stroke. Within the first 48 hours, as the primary injury unfortunately causes cell death, the brain doesn't just give up. It immediately engages secondary neuronal networks to try and preserve whatever function it can. Over the next few weeks, it shifts gears, and we see active synaptic plasticity. It's scrambling to form brand new connections. Finally, stretching over weeks to months, you get continued remodeling through something called axonal sprouting. It's essentially growing new nerve fibers to detour around the injury. It's this beautifully orchestrated, evolving process of survival. Which brings us to Section 3, simulating neural networks. Let's shift gears to the digital frontier. Enter BrainGenix. This is an incredible open source project totally focused on advancing what's known as whole brain emulation, or WBE, alongside clinical neuroscience. Because they operate under an open source license, their whole mission is to provide this modular, reproducible tech stack. Basically, they want to let researchers digitally emulate these insanely adaptable biological pathways right on their own computer hardware. Let's move to the pipeline and see how this builds out. To create this complete digital model, BrainGenix uses a 3-step process. Step 1 is the Scan Translation System, or STS. This takes actual physical data, like electron microscopy scans of a real brain, and converts it into a digital model. Step 2 is the Neuronal Emulation System, the NES. Think of this as the engine. It actually executes the biologically realistic neuronal simulations. And finally, step 3, the environment rendering system, which generates virtual environments and sensory translations so the emulated brain actually has something to interact with. I mean, it is a massive, complex undertaking to digitally simulate the plasticity we've just been talking about. Okay, but it's not all good news. Section 4, when plasticity goes wrong. Yeah, so this is known in the medical world as maladaptive plasticity. See, if you repeatedly feed the brain negative inputs like chronic stress or nociceptive pain signals, the brain, doing what it does best, will wire itself to get better at processing that pain. It learns the wrong lesson. This leads to chronic pain loops and central sensitization, where pain becomes amplified and completely detached from the original injury, sustained just by the brain's new network setup. We also see this in phantom limb phenomena, where the brain reorganizes its sensory maps in a really painful way after an amputation. Or even use-dependent dystonia, like severe writer's cramp, where repeating abnormal movements literally miswires the primary sensory cortex. So, what do? How does medicine fight back against a miswired brain? Well, by intentionally steering that plasticity back to a healthy state, using targeted, task-specific therapies. For example, vagus nerve stimulation paired with rehab has been shown to produce really meaningful gains in stroke patients by actively promoting healthy rewiring. For phantom limb pain, there's mirror therapy. This is wild. Patients watch their intact limb moving in a mirror, and it actually tricks the brain into reorganizing its networks to alleviate the phantom pain. And for stroke recovery, constraint-induced movement therapy forces a patient to use an affected limb by restraining the healthy one. That repetitive practice physically increases activity in the premotor cortex. It's literally forcing the brain to fix itself. All right, let's bring it back to you. Section 5, Habits for Cognitive Fitness. Dr. Andrew E. Budson over at Harvard Medical School summarizes this whole concept perfectly. He says, neuroplasticity is the brain's ability to learn, remember, and change when it is appropriate for the circumstances. So think about those subtle everyday scenes we mentioned earlier, reading a complex book, meditating in a quiet room, or fumbling through the first few chords on a piano. These aren't just fun hobbies, right? They are literally neuroarchitectural tools you can use to redesign your mind. Harvard Health actually highlights several daily brain boosters you can use to build up your cognitive reserve. And cognitive reserve is basically your brain's defense system against age-related decline. First off, challenge your brain with new skills. If a crossword puzzle is too easy for you, you aren't rewiring anything. You have to engage in lifelong learning and really mix up those mental workouts. Next, cultivate active social connections. Interacting with other people stimulates incredibly complex attention and memory networks. Manage your stress. Maybe try some mindfulness meditation, which we know promotes structural changes in the brain regions responsible for regulating emotions. And finally, what you put on your plate absolutely matters. Adopting the Mediterranean diet or the MIND diet, which are heavy on leafy greens, berries, nuts, and healthy fats, actually reduces inflammation and physically supports brain health. And speaking of diet, here is a fascinating number for you, 20. Your brain makes up only about 2% of your total body weight, but it greedily consumes 20% of your body's energy. 20%. That means high-quality nutrition and avoiding those high-fat, highly refined sugar diets is absolutely critical. Why? Because eating a ton of sugar and processed foods can actually decrease the neurotrophins your brain desperately needs for all this plasticity we've been talking about. So the crucial point is how we generated those neurotrophins, which brings us to our next magic number, 150. That is the minimum number of minutes of weekly aerobic exercise recommended to protect your brain. And here's why. Aerobic exercise triggers the release of something called brain-derived neurotrophic factor, or BDNF for short. Honestly, BDNF is essentially Miracle-Gro for your brain. It's a key protein that promotes cell growth and actively strengthens those neural connections. But look, all that hard work during the day requires some serious downtime to actually set in. Sleep is non-negotiable. Adults need 7 to 9 hours a night, and actually, scratch that old myth. This need does not decrease as you get older. Sleep is the critical biological window when memory consolidation happens. It's the time when those short-term memories and newly formed skills physically wire themselves into permanent long-term neural connections, all while the brain literally clears out cellular toxins and repairs itself. It's doing the night shift maintenance. Which leaves us with one final, hopefully empowering question for you. How will you rewire your brain today? The science is abundantly clear here, guys. Your brain is not a fixed asset. It is a continuously evolving, highly plastic masterpiece, and it's being shaped by every single experience, thought, and action you take. So go out there, pick up that difficult book, learn that tricky new skill, go for that 30-minute run, and take active control of your own neural pathways. Thanks so much for exploring the incredible science of neuroplasticity with me in this explainer. Keep learning, keep growing, and I'll catch you next time.